All right. Welcome to my presentation over z-scores. And to get started, z-scores are simply you're looking at the raw score in terms of standard deviation to see if a student did better or did worse, and we can compare it across, of course, genders, grades, etc. So my question is simple. It is simply about whether or not students from 4th to 5th grade reading are increasing or decreasing based on that standard deviation, because it's important to know just because the raw score, for instance, we go from 9 to 8, that does not automatically mean that the student did worse, or vice versa. If we start from a smaller number and we grow, like this one, 20 to 29, that's a pretty big gap, but it still doesn't prove necessarily that that student is improving at the rate they should until you begin to look at the z-score and look at the standard deviation among the others. So just to kind of get started in how we got our information, was actually we started with our for box plots. I had the 4th grade and 5th grade scores for the 2017-2018 and then the 2018 and 2019 STAR reading. So what I was wanting to do was to compare those from my 4th graders going into 5th graders to see if they are growing or if they are not doing much better. So to do that, I took our data from last week, and you'll see that right here, and I put it in light gray just to keep it straight to see kind of what we're doing. And then to be able to get this z-score, to get that actual formula, you actually need to kind of have a little bit of information. So I was already given the student score. However, I had to find the mean and the standard deviation. Now, I would absolutely love to do this for my district, but for purposes of learning, I followed Dr. Cooper and learned how to get it from the TEA website. So to find this mean and standard deviation, I do want to walk through so I'll remember in the future of how we were able to gather that data. So you simply are going to go to the TEA's website, and I think I have it pulled up right here. So when you're on the TEA website, now I'm just going to kind of backtrack to show where I was. But when you're on the TEA website, you just type in mean p-values. And of course, that's just those average p-values that you need. And then it's going to break it up into technical digest, and it's based on the year of the exams. So for instance, I was doing 2017, 2018, and 2018, 2019. So you simply would click it. And now there's a whole lot of information in the beginning chapters, but where our focus is in Appendix B, and it's also going to be right here where it says mean p-values. It pulls up all of those values that we're looking for, because remember, we're trying to get the standard deviation and the mean. So you just simply go to what you're looking for. Anything in blue is a hyperlink that will take you to the total. So you could do there's your ethnic groups. You could do tested with accommodations, not accommodations, and so on. So for 2018, I believe that was my 4th grade actually. And I did total group, and scroll up just a little just to ensure you have the right chart. And this is grade 4 total group. And what I did is I actually snipped it. I have it saved on my toolbar actually. And I just use that snippet tool to copy and paste those pictures. But for instance, I could do math as well. If I had the raw score in math, I could do math, which I would be interested to see that as well and compare it with reading. But of course, we just did reading, and our main focus is the overall test. And then of course, here's your mean and standard deviation. So where I found the 23.98 and 7.59 is exactly out of this table, and I have included it in my Excel sheet just so we are able to see. And here's that one right here, the 2018. So we can see those numbers. So I did that for the 4th grade, and then those 4th graders that became 5th graders in 2019, and got that same information to be able to look at and kind of course, this is descriptive, but we can describe the data we see and make inferences, from there. And then of course, we're going to learn a little bit more as we go on into the semester. But to be able to get this score, of course, it is just simply, you can either do equals, and you're just taking that raw score, right? And I actually put the formula here just to remind me, but we have that raw score minus the mean, and you're going to divide it by the standard deviation. So here was my mean, So I'm going to take the raw score, subtract it from the mean, and then divide it by the standard deviation. And that actually gives me the C-score. Now, the reason we put those dollar signs is because we don't want it to create a pattern, like Dr. Cooper said, so you do want to add the dollar signs or F4. That way, when you drag and copy this formula all the way down, it does not create a pattern. It actually uses these real numbers instead of going something like 15, 16, 17, 18, which will happen. So you have to be careful with that. So I started with that first, and as you can see, these Z-scores are on both. So what that simply means is this is how far away it is from the mean. So we know if you're looking at the curve, then 50% are going to be to the left of the mean and 50% are going to be to the right to the mean. So you can see based on this deviation that this student falls a little bit short, where if you look in the positive, for instance, this student is going to be on the right side. Now, to be able to really describe and really determine to answer my question whether or not the student who made 15 here and 15 here, is he or she growing, or are they staying the same? Based on the number, it looks like they're staying the same, but we want to figure out that answer. So you're going to want to definitely do probability C and probability A, because that is where you can compare. Basically, C is going to be anyone that made lower than this student. And probability A is going to show that percentage of students that did better. So for instance, based on the raw score 15, this person, there was around almost 12% made lower, whereas 88% did higher. So you can see, due to that deviation, this student didn't do so well, according to this, because probability C, like I said, means this is the percent that did less. So only 12% did less than this student, whereas 88% did higher. Now, if we look at the same 15 raw score for the 2019 school year, we can see that these numbers are quite different. Now, we went from 12% down to 0.05, and look how many more students did better. So despite it being 15 and 15, really the fifth graders, when they became fifth, the fourth became fifth, from looking at this chart, that probability, more students did better than him in fifth grade, or her, than they did in fourth grade. So if we were going to say they stayed the same or grow, I would have to say, based on the description, that that is not the case, that this student didn't grow like he or she should have compared to the other students, because 95% of the students did better than he or she did. So compared to 88% to 95%, that is a pretty big gap. What, 7% increase? Students did better than him. So in all honesty, he really fell short and was a little bit less. So really, this is just how you can describe. Now, there's so many different students with the raw scores, so you would have to go through and depict each one, and simply look at it. But let's look at maybe one at 29 to 28. So it's not a big change, but you can tell by looking at that probability for A, which is going to be on the right side, that did better. That is a pretty big increase. So even though it was 29, 26% did better here, right? Because this student is sitting on the positive side, so they did better, right? The standard deviation, a little bit better than the average, or that mean, that middle number. But so 75% did worse, and then the other 25% did better. But if we flip it over, his raw score actually drops by 1. But if we look here, deviation is still in the positive, but right here you see a difference where we had 75 did worse than this person. Here, only 55% did worse. So you can see during this time, the total population actually did better. They did better the second round. And let's look at who did better. So to start with 29 roll, there was around 25% that did better. But look how much in fifth grade does better. 45% does better. So even though the raw score only drops by 1, that is a significant difference, almost double. More students did better this time around in fifth grade than this student did. So this is just a awesome way. I actually love the Z scores, being able to compare. I had no idea you could do this. And then I just put this to remind me of how we got it so I could play around and do more. But really, these z-scores are just showing, you know, just because a student is making 18 last year, 18 this year, doesn't mean necessarily really anything until you pull up the mean and the standard deviation and begin to describe and look and analyze at those numbers to really see what happened. Because as we can tell, and as I've proved here, those numbers don't mean anything until you look at the z-score, look at the probability, and really compare your numbers if you're wanting to see if growth is happening or if there's an opportunity for growth that needs to be looked at between grade levels. So I love this. I think it's very interesting the way it is designed. Like I said, I had no idea you could do that, or even Excel already had these types. The equal, normal, S distribution, I had no idea that those formulas were in there. So I definitely look forward to using this. Of course, I did see where you had the bell curves, where if you, or excuse me, not the bell curves, but the distribution. So that way, if you don't want to look at the chart, then of course you can figure it out here where it also shows below and above those percentages based on where that deviation is in the middle, that z-score is. You can determine what's the percentage below and the percentage above, because we know the 0% will be in the middle because 50% is always higher and 50% is always lower because it's right in the middle. So just interesting. Like I said, I had no idea. And this was one of the ones I felt that was a little bit easier to do. And for me, easier to read, easier to understand by analyzing the data. So I look forward to going back. I saw Dr. Cooper where you said we could actually do, you can see my formula here, but where we can actually do it by our district level instead of the state. The total population is what we have right now for the state of Texas. But I would be interested in looking at my district and campus by campus because there's 8 elementary campuses. And so I would be interested to see the 4th and 5th grade shift between all the campus levels. So maybe hopefully you can help me figure out how to find that information or figure out where actually I would find for just my campus level and district, where I would find the district that standard deviation in the mean, because honestly, I'm not too sure. So as I just look back over my notes, really the bottom line is you can't go by the raw score. You have to analyze and look at the information to be able to figure out, are you slightly above, slightly below, and where does that person fall compared to the rest of the population. So I look forward to working with this one more. Like I said, it's one that's easier for me, easier to see the numbers, easier to play with it and adjust numbers to really understand, is there growth happening or is there not growth happening? So that is what I learned, and my question was answered that it really varies. There's no definite answer on whether or not, in my opinion, that the student is necessarily, it's based on an individual. It's not, I can't look at all of these individuals and say, oh yeah, from 4th to 5th they grew, or automatically say no, 4th to 5th they decreased. It is definitely an individual person, and I would have to look at it like that. But possibly in the future, you can show us maybe how to look at an average overall to see overall did they increase or overall did they decrease based on the population. So I look forward maybe to learning that in the future. But other than that, the z-scores, I like them. So thank you. Thanks.